Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday Night Math Night. I am so excited to be here with you guys for our last Wednesday Night Math Night of 2022. The next time you see me will be in 2023. So we are going to have some fun tonight, that's for sure. I have some fun problems that we're going to do just so that we can just, have a little bit of fun before the holidays. So if you've been with me before, you know that I like to get to know everybody in the room before we get started. So in the comment box, let me know where you're from, what test you're prepping for, and what's going to be my special question today. Ooh, do you like snow or do you not like snow? That question is coming at you because supposedly in Central Florida, we are have a 30% chance of snow on Tuesday. So that's just wild to me. It's supposed to be the coldest Christmas we've had since the 1930s. And we have a 30% chance of snow in Florida, like Central Florida, not the Panhandle. So do you like snow or do you not like snow? I love snow. I love the mountains. We live in Florida, but neither of us are beach people. We would much prefer to be in the mountains and in the snow. So where are you from? What test are you prepping for? And are you a snow person or not a snow person? Meredith, you'll have to hit me up on Tuesday if it snows. Where are you at since you're from Orlando, Florida? Prepping for the GK Math. Awesome. Hey, Milagros, it's good to see you. I'm glad that you had fun on Saturday doing one-on-one tutoring. That is something that both Priya and I offer. So if you are hanging out in here, just a little plug. We do a one-on-one tutoring too. So if the problems you see here, you're like, wow, that was awesome, but I really need some targeted help, we do offer one-on-one tutoring. So that said, let's go ahead and get started with our first problem. If you see something, or if you're not seeing what you want, you're like, man, I wish we did more, polynomials, or I wish we did more parabolas, or I wish we did more factoring, whatever. If there's something you're specifically struggling with, please let me know in the comment box. It helps me help you on these Wednesday night math sessions because these are for you guys. They're free, so you might as well get the most out of it. You're from Mississippi. Hey, Bernadette. You don't see much snow in Mississippi. We don't see much snow here in Florida either. And you're prepping for 7 through 12. Awesome. So we're going to do a little bit of everything tonight. Let's go ahead and get started. Hey, Hope, it's good to see you. I haven't seen you in a while, so it's good to see you. All right, this problem is for everybody. Knowing how to interpret function tables is extremely important. So for my elementary people, you need to understand patterns of inputs and outputs. Everybody else, GK core, middle school, high school, you need to understand not only the pattern, but how it behaves in function notation and what rules are being applied, and then interpreting those rules and what it means for the graph. So understanding function tables is extremely important. A function, let's define that before we even get started. So a function without the table is a special type of graph that has only one y for every x. Now, every time I say that, I have to literally think like above my head and think about what it means because I just do the vertical line test. So when I think about a function, I'm thinking about on a graph, and I'm going to do a couple different graphs so that you can see what I mean. So we could have a function that looks like this. We could have a graph that looks like this. And we could have a graph that looks like this. So two of these are functions and one of these is not a function. And here's why. When I do a vertical line test, which just means that I'm going to draw vertical lines through this graph, the vertical lines are only hitting my graph one time. So that means it's a function. In this case, when I draw vertical lines through this graph, they are only hitting the graph one time. Now, it looks like this might turn into a straight line, but it's not going to. So this is a function. But when we look at this one, when I draw a line through it, it hits the graph two separate times. So this is not a function because there is more than one y value for that specific x value. That was just a little bonus function lesson. Now let's look at this function table, which means it's a function. I know it's a function because I only have one y value for every x value. I know my input is my x values and my output is my y values. If you're not sure about that, you can always think about that x comes before y in the alphabet and I comes before O in the alphabet. And so therefore, your input is your x and your output is your y. So what is the rule demonstrated by this? What am I doing to the x to then get a y? So when I think of input outputs, I think of what am I putting in the machine and what is the machine spitting out at me? So when you think about like a gumball machine, you put a 25-cent quarter in there and then the machine spits out a gumball. So in the input, I could be multiplying by 4. So 2 times 4 equals 8. Correct. If you stopped there, you would get this problem wrong. And a lot of times with input outputs or function tables or things like that, they will create a correct answer in one of the first two that is wrong because there's a lot of lines that could be multiplied by 4. However, there's also a lot of lines that could go through the point 2, 8 that don't follow that rule. And in this case, that's not the correct answer. And I don't know what your real name is, but your YouTube screen name is ... And yes, I'm so glad you recognize that. Because if I multiply anything else by 4, 4 times 4 is 16. That does not work. 6 times 4 is 24. That doesn't match. And my rule has to match everything. And so in this case, multiplying by 4 is not correct. I put in multiplying by 4 and it did not spit out anything because that did not work. Add 4. So let's take a look at that. 2 plus 4 equals 6. Already, I know that that doesn't work. Divide by 4, or divide by 2 and subtract 1. 2 divided by 2. Well, 2 divided by 2 is going to be 1. I'm going backwards, not forwards. So that's not going to be correct either. Multiply by 2 and add 4. So I'm just going to redraw my input-output table down here because I ran out of room. Input, output, 2, 4, 6, 7, 8, 12, 16, 18. So multiply by 2 and add 4. 2 times 2 is 4, and 4 plus 4 is 8. That works, but I'm going to test more than one. 4 times 2 is 8, plus 4 is 12. That works. I'm going to do one more. 6 times 2 is 12, plus 4 is 16. We found our rule that works. So our answer is D. Any questions about that problem? And like I said before, let me know if there's something very specific you want me to work on in the upcoming weeks, because I'm more than happy to add very specific problems that you want into our Wednesday night math sessions. All right, we have another function table, and this time they want to know the rule that is demonstrated in an equation form. So this kind of problem is really going to probably be more what you see on a K through 6 exam. This problem is going to be more what you might see on a GK or higher. So I will come back to that, Milagros. A function table is shown below. What is the rule that is demonstrated in the table? So when I look at my table, I can't immediately see a rule that's going to necessarily work. So when I think about this, -1, 6. So if I graph this, -1 up 6, over 0 up 3, over 2 down -3, and this is not going to be correct. So I didn't, when I typed this problem, I didn't change that number. So we'll just go with what we have right here, these 3 points. Okay, so the first thing I'm going to do is notice that my y-intercept is +3. How do I know that this is my y-intercept? Because when I'm looking at a graph, and I actually already have a graph, when I'm looking at a graph, my y-intercept is the point at which the graph crosses the y-axis. When I look at my answer choices, because when you're taking an exam, it's important to use all the information, especially on a math test. So when you're looking at these answer choices are all in y equals mx plus b form. Like I said, I don't know what your real name, but screen name ... I will circle back to that at the end and explain what we can do to help you not feel so nervous. But don't be nervous. I completely understand this is a lot of information, but our motto is not if you pass, but when you pass. And if you put in the work, and I will give you some resources at the end that you can use, you'll have it. Okay, so these are all in slope-intercept form. Mathematicians are not creative in the way they name things. Slope-intercept form is literally named that because it provides you with a slope and a y-intercept. So if I can identify my y-intercept from my input-output, that's going to help me eliminate answer choices. My y-intercept is 3 because a y-intercept is going to be where x is 0 because it's on the y-axis. So if this value is my y-intercept, which answer choice can I get rid of off the bat? C. Now, if this was me taking this test, I would want you to be able to see that pretty immediately. That just took me 3 minutes to explain to you because I'm trying to give you a lot of perspective. However, when you see this and you're like, okay, function table, what is the rule? I look at my input output and I immediately know that 3 is my y-intercept and C is out. That would be the process I would want you to eventually be able to get to. Now, the rest of them, the only difference is their slopes. So we have a slope of 3, we have a slope of 1, and we have a slope of -3. Which is the only one it can be based on the graph that I graphed here? D is the only one. Let me give you a hint why. D is going to be our answer. Excellent job, Hope. D is going to be our answer. Here's why. Because when we take a look at graphs, I have graphs that could go like this, and I have graphs that can go like this. There's a lot of other linear types of graphs. They can go up and down or side to side. However, those are the two main directions a line can face. This one right here is going to be a positive slope, and this one right here is going to be a negative slope. Why? Because I read my graph from left to right. And when I read my graph from left to right, I think about the direction that my car would be driving. So on this one, my car would be driving up, which is a positive slope. And on this one, my car would be driving down, which is a negative slope. Well, in this case, if I read the graph from left to right, I'm going down, which means we have a negative slope, and D is the only one with a negative slope. Now, with that said, how would I solve this if, let's pretend letter B was a negative? And now I've been able to eliminate A, but I don't know if it's B or D. In that case, we would have to find our slope. So I can use my slope formula to figure that out. Remember, slope equals rise over run, or the difference of our y's divided by the difference in our x's. Now, if you're taking the GK, you get a reference sheet. And the reference sheet's going to have the slope formula look something like this. And when you look it up, it's going to look something like this. However, those 2's and those 1's really don't matter. It doesn't matter if you do y2 minus y1 and x2 minus x1, or if you do y1 minus y2 and x1 minus x2. It does not matter. What matters is that you're consistent with the point that's first. So if you do y2 first, you can't do x1 first. So let's go ahead and find the slope of this input-output table just so that you can see how we would do it. So I'm going to pick 2 points. Doesn't matter which 2 points. I could pick these 2, I could pick these 2, or I could pick the first and the third. Doesn't matter. I'm just going to pick the first 2 points. So remember, this is my x, this is my y. So I'm going to do 6 minus -1 divided by 3 minus 0. What is 6 minus -1? A positive, so that becomes 7 over 3. That's hilarious. This isn't even the right answer. Now, if we did the next 2 points, y, oh, duh, because I did y minus x. I didn't even do that entire problem right. That's why. Okay, let's try that again. I did y minus x divided by y minus x. See, we all make mistakes. We have to do y minus y. So 6 minus 3, y minus y, divided by x minus x, -1 minus 0. So 6 minus 3 is 3, -1 minus 0 is -1, which gives us a slope of -3, which makes a lot more sense. Input is x and output is y because x comes first in the alphabet, and so does I. Absolutely. Good job, Milagros. All right, let's go ahead and move on to the third problem. Ooh, this one's fun. Okay, what is the area of the shaded figure below? This one is super fun. Okay, everybody needs to understand area. Everybody needs to understand area. The capacity to which this problem is written is not necessarily for everybody, but there's pieces and parts that everybody needs to understand. So that said, I need everybody to understand this problem and the problem solving process that we go through, but not everybody needs to know how to find area of a circle specifically. However, what if the problem was something like this? What if it was something like this and it said find the area of the shaded areas? Not everybody needs to know how to find area of a circle. However, everybody needs to know how to find area of a square and area of a triangle. So the process that I go through with this week is for sure something everybody needs to know. You had one of these problems last week? Yes, we did. The one we did last week was, what was it? It was something like this. Wait, it was like a square and then like this, but then it was like these pieces were cut out like this. So this is a different one, but yes, you're absolutely right. This is very similar to what we did last week. All right, so let's go ahead and solve it. 8 centimeters is the length of our square. And really, this should say either what is the area, or it would say something like below you will find, no, below is a square with 4 circles inscribed inside. Or it would have something like this. Okay? Here's why. Because we can't assume this is a square and we can't assume those are circles. So something about this problem, yes, Hope, 6 minus 3 divided by -1 minus 0. I totally messed that up. So something about this problem has to identify that we have a square, whether it's in the words or it's in the actual problem. So knowing that it's a square with 4 circles inside, let's go ahead and solve it. Let's come up with a plan before we solve. In order to solve this, what do we need to know? We need to know the area of the square. We need to know the area of one circle. We need to multiply the area of one circle by 4. And we need to subtract the area of the square minus the 4 circles. I will often create some sort of plan for lengthy problems like this because I don't want to miss a step. So, yes, area of a rectangle or a square is length times width. So, the area of my square, and I'll often identify what I'm working with little symbols like this so I don't get lost in my work. So area of the square is length times width. Because it's a square, I know that this side is also 8. So 8 times 8 is 64. Part 1, check. Now I need to find the area of my circle, which is pi r squared, where r is my radius. How am I going to find my radius? My radius is going to be the distance from the center of my circle to the outside. 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 But these circles are perfectly inscribed inside, which means But if I drew a straight line all the way across, what would that be? 8. And these circles are perfectly inside here, which means this diameter is 4 and this diameter is 4. 4 plus 4 is 8, right? And this diameter is 4, and so is this diameter. The diameter is the distance from one end of a circle to another end of the circle going through the center. Keep that in mind. This is not a diameter. That's a chord. A diameter has to go through the center. A radius is just half of that. So if the diameter of all my circles is 4, then the radius is going to be half of that, which is 2. So I have pi times 2 squared. Pi can be defined as 3.14, and the problem will say use 3.14 for pi. So 3.14 times 4. And at this point, I'm going to pull out my handy dandy calculator, which I guess I'll have to use my computer one. Normally I have my phone calculator, but don't know where my phone is. That's not a surprise. So I'm going to use my computer calculator, which is 3.14 times 4. 12.56. So the area of what is 12.56? What did I just solve for? One circle. And I'm going to change my perspective here so that you can see everything I'm doing. One circle is 12.56. So check, I've done step 2. This is why I'm checking things off, and this is why I create a plan. Because it would be very easy for someone to do 64 minus 12.56 and be done. And that answer is right here. And that's not what we're doing, because that's only one circle. How many circles do we need? 4. So I have to multiply this value by 4. Which equals 50.24. And now I can subtract 64 minus 50.24. (64) minus 50.24 equals 13.76. I just realized that all of the answers so far tonight are D. 50.24. Yes, 50.24 is the area of all 4 circles, and then you're going to do 64 minus that. Absolutely. Bernadette, I promise that as you do more of these problems, they become easier to plan out. This problem, when I solved it independently, did not take this long. But if this is a problem that you're like, whoa, don't know how to do it, and this doesn't go just for Bernadette, this goes for everybody in the room, skip it, move on. As Dr. A likes to say, make sure you go after that low-hanging fruit first. So you're going to go after those problems that you're like, man, I've got that problem. If you get to this problem and you immediately see that and you know that you are not comfortable with it, mark it at the top and move on. Don't waste time sitting here stressing about it, because all you're doing is wasting valuable time. Hit that low-hanging fruit, then go back and do your marked problems, because then you're guaranteed to at least hit all the problems you're comfortable with. All right, problem number 4. You and some friends are playing a game of catch. You throw the ball 5 feet forward to friend A. Then friend A throws the ball 8 feet backwards to friend B. Then friend B throws the ball 4 yards forward to friend C. Then friend C throws the ball 2 feet backwards to friend D. Where is friend D standing in relation to where you are standing? All right, So we're playing this game of catch, and they're doing it in this straight line format. I've never played catch in a straight line personally, but that's just me. Doesn't mean that can't happen in mathematic world. Oh my goodness, it makes me think, and I told you we would have fun today. It makes me think of that meme. Have y'all ever seen that meme where it's like only in math problems does somebody go to the store and buy 64 watermelons and not question anything? I saw that the other day and I was like, that is so true. In math world, we ask the most ridiculous things. You know, Johnny goes to the store and buys 64 watermelons for his, birthday party. Why are you buying 64 watermelons? And, then he drops 3 of them. How many are left? Like, those are the kinds of problems we see, and it's really funny. Anyways, moving on. This is kind of one of those problems. I'm glad I'm not the only one that saw that. So this is one of those problems. I've never stood in a straight line and been like, hey, catch. And then they're like, hey, catch. But you know what? It's the math world. So this is how we're playing catch. So we're all standing in this straight line. And I'm standing right here. A. You throw the ball 5 feet forward. Oh no, this is you. You throw the ball 5 feet forward to friend A. Now, I want you to think about what a number line means. When we think about a number line, forward is the positive direction. Backward is the negative direction. So we're going 5 feet forward. 1, 2, 3, 4, 5. And it lands on friend A. Then friend A throws the ball 8 feet backward to friend B. Now, think about where friend A is sitting. It's not going to be 8 feet backward from here because that's where you're standing. Friend A throws it 8 feet back from where they are standing. So we go backwards 1, 2, 3, 4, 5. 6, 7, 8. And that is where friend B lands. Where is that in relation to you if you are 0? -3. -1, 2, 3. Then, so that was orange. Then friend B throws the ball 4 yards forward to friend C. 1, 2, 3, 4. Do not make that mistake. That's going to be the number one mistake people make. How many tick marks should we be jumping? 12. You're like, 12? But the problem says 4. You're absolutely right. The problem says 4. However, it says 4 yards. And everything else is in feet. So we have to convert it. Absolutely right, Bernadette. Equals how many feet? Well, if I know that 1 yard equals 3 feet, what am I doing to this to get to 3? Am I doing 1 divided by 3 or am I doing 1 times 3? 1 times 3, which means I'm going to do 4 times 3, which is going to give me 12. So friend B throws the ball 12 feet forward. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And C lands there. And then friend C throws the ball 2 feet backwards to friend D. 1, 2. So the question asked, where is friend D standing in relation to where you are standing? So if you are here at 0, friend D is at 7. You're absolutely right. Now, we're going to take all of this and look at another problem. So I'm just going to cut and paste this. Copy. Same exact problem. Same exact problem. However, the question is different. So I'm not going to read through the problem, but I wanted to show you that the way a question is worded could totally change the way we solve it. Because let's be honest, with any one problem, they could ask us 1,000 questions. So in this case, did I lose you guys? Oh, Lordy. Okay, my TV setup like totally unplugged because I whacked the cord. So can you still hear me? Give me like someone tell me that you can still hear me and that we're still connected. Someone tell me that you can still hear me and that we're still connected. Hopefully you can. Share screen. Okay, perfect. Okay. Beautiful. Okay, so lots of problems show. Oh, hey, Terry. Good to see you. I haven't seen you in a while. Okay, moving on. So lots of problems, or one problem could ask a lot of questions. So in this case, the question is, all of this is the same. But the question says, what is the difference between friend D and friend B? So what does difference mean? Difference means subtract. And so when I look at this, I'm looking at the difference between friend D and friend B. So B is at -3 and D is at 7. We already determined that. So 7 minus a -3 is going to give us what? 7 minus a -3 is going to give us 10. You're absolutely right. Come on. There we go. 7 minus -3 is going to give us a +10. Difference just tells us what is that gap between those 2 points. So the gap between those 2 points is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. Let's move on to problem number 5. Someone specifically asked for an apothem problem. And so I found this really cool apothem problem. The apothem of a square having its area, you said this problem has meters. Oh, it does. That's a typo. I am so glad that you noticed that. That was a typo. This should have said yards. Thanks. All right. The apothem of a square having its area numerically equal to its perimeter is compared with the apothem of an equilateral triangle having its area numerically equal to its perimeter. The first apothem will be. That's what my brain is doing after reading that. Okay, please, these are the kinds of problems that you will see on an exam. You'll see the other ones for sure too, but these are the ones that really trip my friends up. And I hate it. I hate that that they're so confusing. I want you to see that you know how to solve this. Now, if you don't know what an apothem is, you're up a creek without a paddle. If you know your vocabulary, you will be fine. So let's look at this. Here we go. The apothem of a square. Let's draw a square. There's my square. And it says, having its area numerically equal to its perimeter. Why couldn't they just say the area is equal to the perimeter? Why do they have to make it all fancy? I don't know. Fancy is what, is unfortunately what makes people not pass. Because our brain thinks, I don't know what that means, but you do. The area numerically equal to its perimeter just means that the area is equal to the perimeter. Area equals perimeter. That's all that means. Okay, so the apothem of this square, and the apothem goes from the middle at a 90-degree down. I don't know why my iPad keeps disconnecting like this. I apologize, guys. So the apothem is the line segment that goes from the midpoint of the shape down to a perpendicular angle to one of the sides, okay? So when we look at this square, it goes from the middle straight down at a 90-degree angle. In a square and a rectangle, it's pretty easy to figure out. It's those triangles or the hexagons or whatever that make it more difficult. So that apothem is compared to the apothem of an equilateral triangle. So now I'm going to draw my equilateral triangle and draw an apothem. There's my apothem. And the equilateral triangle also has its area numerically equal to its perimeter. The area is equal to the perimeter. What do we know about the apothem? Well, in this kind of situation, I like to try to figure out some numerical values so that I can really dig into this problem. So I could sit here and go, 1 times 1 is 1. Length times width is 1. But then 1 plus 1 plus 1 plus 1 would be 4. So that's not 4. 2 times 2 is 4. But 2 plus 2 plus 2 plus 2 plus 2 is not 4. I could do that. Or I could solve it algebraically. So high school people, this is the kind of problem you're going to see on your exam, and you should understand what I'm about to do. And if you don't, it's okay. You've just got some studying to do. So I'm going to identify this as S and this as S. I know that S times S has to equal S plus S plus S plus S. The area, length times width, has to equal all the sides being added together. Agree? So now let's solve that. S times S is S squared, has to equal S plus S plus S plus S, which is 4S. Now, I could solve this one of two ways. I could divide both sides by a S, and that gives me S equals 4, or you could solve it by factoring. I'm not going to go there right now because I want to get through this problem and a couple more. But that tells me that the sides are 4. Does that make sense? Is 4 times 4 the same as 4 plus 4 plus 4 plus 4? Yeah, 4 plus 4 plus 4 plus 4 is 16. 4 times 4 is 16. So I can replace all of these S's with a 4. That means my apothem is 2. That only works for squares and rectangles. It's not going to work for our triangle. However, let's move on and figure out the rest of this. So the apothem is compared. We already figured out what the sides equal. All of that has just now become irrelevant. I'm not going to keep it crossed off, but I want you to think about that because now I need to think about this. The apothem is compared with the apothem. We have to compare the apothems. So now I need to figure out what the apothem is of this triangle. Well, I can go ahead and figure out that the sides of my triangle first. So if this is S, this is S, this is S, then the area, 1/2 base times height, has to equal S plus S plus S. Bear with me. 3 S's, perimeter, has to equal 1/2 base, which is S, and what is this height going to be? I have to do A squared plus B squared equals C squared. So B is S divided by 2. A is what we're looking for, and C is S. So A squared plus B squared equals C squared. a squared plus b squared equals c squared. Now I have to multiply everything by 4 to get rid of that fraction. So 4a squared plus s squared equals 4s squared. Subtract s squared from both sides. 4a squared equals 3s squared. How do I get a by itself? Divide both sides by 4. I'm going to continue over here. So a squared equals 3 divided by 4, s squared. Square root both sides. And we get the square root of 3 over 2s. If you are not taking the high school exam, you don't need to know most of this. So if you're confused and you're not taking a 7 through 12 exam, don't worry about it. We will get to another problem that you need to know in a minute. Okay, so that is the measurement of that is the measurement of the height of this triangle. Why was I trying to find the height of the triangle? Square root of 3 over 2s, so that I can find the area of this triangle. Square root of 3 over 2s. Third time's the charm. I'm hoping this MacBook does not disconnect again. So now that I have that height, now I can compare my area and my perimeter and hopefully get a measurement for one of my sides. So now I can take that information and multiply all of this through. So I have the square root of 3 over 4. Ooh, that's really thick. The square root of 3 over 4s squared equals 3s. Divide both sides by s. The square root of 3 over 4s equals 3. Multiply both sides by 4 over the square root of 3. And s equals 12 divided by the square root of 3. That is what s equals. Okay, now we can use that information to figure out what our apothem is. So the apothem of an equilateral triangle has a relationship of trying to think. Give me a minute. 12 divided by the square root of 3 is what we got. Where did I get? So the apothem of an equilateral triangle has a relationship. So apothems are weird because the apothems in all different shapes have this weird relationship that, like, if we memorize, it just makes your life a lot easier. So the apothem of an equilateral triangle is going to have a, and I need to look it up for you guys, of equilateral. I had it written down, some equilateral triangle. I had it written down. This is the kind of stuff that, like, you just have to put in your memory. So the apothem of an equilateral triangle is A equals S divided by 2 divided by 3. Why? There's a proof somewhere in the world, but to be quite frank with you, when I was studying for this test years ago, I didn't need to know the proof because for certain things, I just needed to be able to memorize it and move on. If you need to know the proof, go look it up. Proof of why I'm sure there is an algebraic explanation. I just wasn't that person. So I can plug in the side of my triangle into this. So 12 divided by the square root of 3 divided by 2. But when we divide fractions, we keep change flip. So it really is just going to turn into multiplying by 1/2. and then divided by 3. So this turns into 6 divided by the square root of 3. This is the square root of 3. I'm sorry. I got that relationship wrong. Divided by the square root of 3, or times 1 divided by the square root of 3. 6 times 1 is 6. The square root of 3 times the square root of 3 is 3, and 6 divided by 3 is 2. So the apothem of this triangle is 2, which means that the apothem of my square is equal to the apothem of my triangle. Like I said, knowing the relationship of apothems is important if it's in your blueprint. To be quite frank, not every high school test has apothems on it. So if this is something you're like, wow, that's really cool, I'll tuck it in the back of my brain just in case, great. This process is really probably more of what you might need to do. Memorizing the apothem, not so much. But this, if you did not understand that, you definitely need to understand how to manipulate variables like that, okay? All right, let's go ahead and do, I have this really fun problem. Okay, this is another high school problem, but everybody is gonna enjoy this problem, okay? So everybody should have fun with this problem. Even if you don't need to know how to do this, just pay attention because it's gonna be so fun. So y equals ln of x divided by m minus sa divided by r squared. So how are we going to solve this problem? So this is a problem very much like the problem that I just solved, where you just need to understand how to manipulate variables. If you don't understand how to manipulate variables, or you don't understand how when you do one thing to one side, you have to do it to the other side, all of that is really critical for everybody. So like if you add something to one side, you have to add it to the other side. If you multiply something by one side, you have to multiply it by the other side. Otherwise, it's just not going to work. So even though the idea of like natural logs and squares is not for everybody, understanding that what I do to one side, I have to do to the other side is critical for everybody. So let's go ahead and get started. So what am I going to do first to simplify this equation? The first thing I'm going to do is multiply both sides by r squared to get rid of this fraction. Now, you may not need to be able to do this. However, if you had something like 3 equals 4 divided by x, that would absolutely be something that everybody needs to know how to solve. Everybody would need to understand that multiplying by x over 1 would cancel it out over here, and then I could multiply by x over here. So like I said, this exact problem may not be something you need to understand how to do, but you certainly need to understand how to solve this kind of problem. So multiply both sides by r squared, this cancels out. So I have r squared y equals ln of x divided by m minus sa. Now, everything within that is trapped in ln jail, similar to logs. How do I undo a natural log? How do I undo a natural log? Well, I have to e both sides. So I'm going to e both sides. And that cancels out. So now I have e to the r squared y equals x divided by m minus sa. I'm going to multiply both sides by m. Actually, I'm going to multiply everything by m. And now I have m times e to the r squared y equals x minus SAM. Now I'm going to expand that a little further, and I'm going to expand my r's. ME to the R times Y equals X minus, and I'm going to use the commutative property of multiplication. Commutative, iPad, you're going to ruin my fun moment. X commutative property says that I can multiply in any order. So that means that SAM could also turn into MAS. So I'm going to go ahead and use the commutative property and rearrange that. And now I have Merry Christmas. How fun was that? All right, even if you don't celebrate Christmas and you celebrate a different holiday or you don't celebrate holidays, you have to admit that was pretty cool. Someone sent that to me and I was like, okay, I have to do that on my final Wednesday night math night for 2022 because that was really cool. All right, I get entertained easily. My husband would think that that was so not cool. All that said, we had way too much fun tonight. If you have any other things that you want me to go over in the coming weeks, please let me know in the comments. I hope that you and your family have a wonderful holiday season, whatever holiday you celebrate. I'm going to turn it back over to Dr. A. I know that you said screen name ... You said that you were really stressed about this test. You're not the only one. So many people are stressed about these tests. They're really hard. Here at the Learning Liaisons, we offer one-on-one tutoring. We have boot camps. And the math boot camps, I mean, I'm biased because I did them, but the math boot camps are really good. And we are running a really amazing holiday promotion right now, and it's better than any promotion you'll get. So I'm going to turn it over to Dr. A, and he has a code that's specifically for Wednesdays, but our code on our website is better. So if you will Facebook message me, yes, do sign back up. Absolutely. So sign back up using our code. That's going to help you. And if you need to sign up for one-on-one tutoring, Priya and I are both here to help you. We want to see you and everybody else succeed. So if you have any other specific questions from your boot camp or from your studying, please drop them in the comments or message me. I'm more than happy to add that kind of stuff into our Wednesday nights. I'm going to turn it over to Dr. A. Have an amazing holiday season, and I will see you in 2 weeks when it is 2023. Bye, everybody.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.